So in some cases, it might be necessary to expand or condense before we can solve. So anytime that you have two logs on the same side, you're going to want to condense those first into one. So we're going to take these log base 3's and we're going to make them just one log. And because these two logs are joined by an addition sign here, the x and the x minus 6 are going to get multiplied. So we're going to set this up as x times the quantity x minus 6 is equal to 3. And in order to get rid of this log base 3 here, we're going to turn this into an exponential function. So we're going to take 3, the base here, and make it the base of an exponential, and whatever we do to one side we have to do to the other. So this log base 3 and this exponential 3 will cancel each other out, and on this side we have x times x is x squared, and x times negative 6 is negative 6x, and over here we have 3 cubed, which is 27. And because this is a quadratic, we need to get our equation equal to 0. So we're going to subtract 27 from both sides. And so we get x squared minus 6x minus 27 is equal to 0. So we have two options. We can either use the quadratic formula or we can factor. And factoring sometimes is a little bit faster, so we're going to try and factor this. So the two factors of negative 27 that add to negative 6 are going to be negative 9 and positive 3. So we're going to use ZPP now, and we're going to set up these two equations. X minus 9 is equal to 0 and x plus 3 is equal to 0. We would add 9 to both sides here, so one solution would be x is equal to 9, and we're going to subtract 3 from both sides here, so the other solution would be x is equal to negative 3. So the last thing that we need to do is check for extraneous solutions, which are solutions that look like they're going to work but don't really work. So if we plug a 9 into this original equation up here, if we substitute 9 in for x, we would have log base 3 of 9 and log base 3 of 3. And we can do both of those, so that's fine. However, when we take a negative 3 and substitute it in for the x's up here, this would give us log base 3 of negative 3 and log base 3 of negative 9. And neither one of those is a defined answer. They're both undefined. So x equals negative 3 is actually an extraneous solution, and our only real solution is x equals 9.